Hi, I'm Emil Landwerf, a program manager on the .NET team. And today I'm going to talk to you about our brand new Windows Compatibility Pack for .NET Core. But before we do that, let's take a look at porting to .NET Core to begin with. So there are good reasons why you may not want to port to .NET Core. Historically, the primary reason was we did not have enough APIs in .NET Core. And with .NET Core 2.0, we already added a ton of APIs to it, and we're continuing to do that with the Windows Compatibility Pack. But still, depending on what you're doing, if you're building Windows Forms app or WPF apps, or if you're using Web Forms apps, you probably should not port to .NET Core yet, because .NET Framework is still the best bet that you can take. And also, if you're happy on .NET Framework, there's also no reason to port, because .NET Framework is a fully supported .NET platform, exactly as .NET Core is and Xamarin is. So if you're happy, it's completely reasonable to stay on .NET Framework as well. And there are, of course, good reasons to port. So the biggest reason why you may want to port to .NET Core is because that's the best way to build highly scalable web apps, because that's what .NET Core is really optimized for. The other big reason is usually because you want to run your web backend on Linux. That's also a very good reason to port to Core. So as I said, we will add a ton of more APIs in .NET Core 2.0, and the Windows Compatibility Pack continues on that venture. So in fact, we add about 20,000 APIs with the Windows Compatibility Pack. So it's quite sizable if you consider the .NET Core has about 30,000 APIs. So it's a sizable upgrade, if you will. About half those APIs are Windows only, and the other half are also cross-platform capable. And the nice thing is it's all deployed as a NuGet package. So referencing it is very simple. It's a single NuGet package you can reference, and then you get access to all these APIs. Content-wise, it has the usual suspects. Windows access controls, code pages, code DOM, and so on and so forth. We have a whole bunch of stuff in there that many of you asked us for, and we are probably continuing to add even more APIs depending on what the feedback is going to be. So as I mentioned, half of these APIs are Windows only, so that begs the question, how do you find out when you want to port this thing to Linux? And the answer is you should install what we call the API Analyzer. It's a Rosin analyzer that will run live in the IDE, but it will also work on the command line, it will work on the CI machine as well. And it will flag all usages of APIs that will not work in a cross-platform way. And so you get rich feedback as you're typing, and you can make decisions on whether you want to remove the API or want to replace the API with a cross-platform API. All right, enough said. Let's look at a demo. All right, so what I have here is a console app. Let's take a quick look at the properties here. So this is a console app that targets .NET Framework 4.0, but it could also be 4.5 or 4.6. It doesn't really matter. And what I have here is a very simple program. Let's quickly run it. So what I do is I get some information about my C$ file share, and I print the properties here. Let's take a look at the source code for that. So I'm using the WMI APIs to get information about the share, and then I print some properties. I'm not using logger. I'm not using console.writeline. I'm using logger.log. So if you look at the code here, basically I use the tracing APIs that we have, and I also use the event log. And the tracing APIs are initialized by going to the registry to find out where the log files should be stored. And if it's not configured, I'm just falling back to some local application data location. Doesn't really matter. And the point here of this demo is not so much to illustrate how to do logging. It's more an illustration of how a general purpose feature, in this case logging, can be interspersed with Windows-specific API calls. And that's quite typical for existing .NET Framework apps. So let's take this whole thing now and copy those files over to a .NET Core application. So if we look at the properties here, this thing targets .NET Core 2.0, which is the recommended target if you want to port to .NET Framework. All right, so now that we have that, let's set this as a startup project. And as we can already see, we get a bunch of errors. So in our case, we get only 5 errors because we don't use the Windows APIs as much. But if you have an existing application, chances are you call these APIs quite a bit depending on the size. So you may easily get hundreds or maybe even thousands of errors. So the very first step to get this under control would be to go to NuGet packages and install the compatibility pack. And the name is Microsoft.Windows.Compatibility. You select the package, you hit install. And as we can see, when we rebuild, it says build succeeded, but the errors there, they probably disappear in a second or so. Yep, and if you run the app, now it's running a .NET Core app, still runs on Windows, so it has the exact same result as you would expect. So now the next step would be, I may want to run this application now on Linux. So let's actually change our code a little bit. I know that WMI, because it stands for Windows Management Information, doesn't actually work on Linux. So let me just delete that. Of course, in a real-world app, you may just change the feature or refactor your code or whatever it is. In our case, we just changed the console app to use the logger APIs to print hello. Before I run it, I also remove my usage of the Windows event log. Again, the name kind of implies it's not available on Linux. So let me just delete that as well. And now the code compiles. So what I have here is I have a terminal window here. It runs Ubuntu on Windows using the subsystem for Linux. So for all intents and purposes, we can treat this as a real Linux app. So let me just run our console app now and see what happens. And as we can see, we get a platform not supported exception. Registry is not supported on this platform. So how do we call the registry? Well, main calls log, which calls initialize, which, as I said earlier, goes to the registry to find where to put the log files. So how would we fix that? Well, first of all, how would we even find out that we have that issue? And to do that, we would install the API analyzer, as it's called. So you would select this, and you would say install. And as you can now see here, I didn't even have to rebuild, but we immediately got 2 warnings. And it tells us that registry key get value and registry key open subkey are not supported on Linux or Mac OS. So we can just double click on this guy and we immediately jump to the location where we see that. And as I mentioned earlier, the nice thing here is this is not just something that you have to run. You can just, as I'm typing in the API name, I immediately get this squiggle, so you get live feedback that you're using APIs that are not supported. So how would I fix the problem? So you have 2 options. Option number 1 is what I did earlier. I could just delete the code entirely. But you may not want to do that. You may want to write a console app that, when run on Windows, still goes to the registry and asks for the logging information. And if you're not on Windows, you just skip that step. Because if you look at this code here, it's already written in such a way that it will work fine if it can't find the registry key. So the most natural choice here would be to say, well, let's see whether we're on Windows. So I have this little snippet here. So I just take the existing code, move it under this if check. And we have this API called runtime information, and you can ask whether you run on Windows. If you're running on Windows, great, let's use the registry APIs. Otherwise, or if we can't find it, we just fall back to the local user profile to store our log files. Now you may notice that even though that we have this if check in place, the warning still exists. And the reason for that is that we can't really analyze your code to the extent where we would be able to tell that you have a platform guard in place. So the idea here is you write your code in such a way that you think it works, you do your testing, and when you verify that everything works as you expect, you just suppress the warning. So just use the Roslyn fixer infrastructure here to say suppress warning in source. This emits those pragmas here. I just move them here, delete the comment here because it's not really adding anything. Do some nicer indentation. But key here is the warning disappeared. All right, now let's actually go back to our Linux machine. I've done the same code earlier, so let me just check out that version of the code. And to prove to you that this is actually the real thing, my logger file here says, warning disabled, but I still call the registry APIs if I'm running on Windows. So now let's just run this guy as well. And as you can see, it works as we expect. So to summarize, if you port code to .NET Core, the first take should be stay on Windows and use the Windows Compatibility pack to maximize the amount of APIs you can use for importing. To do that, go to AKAMS Windows Compat Pack. This will have instructions on how to install the Windows Compat Pack and how to get started. Next, you may want to port stuff to Linux and Mac. And if you do that, try the API Analyzer. And again, go to AKMS API Analyzer. It will have a nice walkthrough and a nice blog post that will tell you exactly how you can get started here. But remember, if you're happy on .NET Framework or if you're building desktop apps or web forms apps, staying on .NET Framework is still the best choice. That being said, happy porting. Thank you very much.